Alrighty. Okay, you guys, the thing to remember is complex and imaginary roots come in pairs. So if I have an a plus bi, I need an a minus bi. So there's these different combinations we can have. I can have, here's my degree, here's 0, but because I can only have one 0, I can only see it once. So it doesn't have a partner, so it can't be two imaginary zeros. So on this one, so degree 2 and 2, I can have two real, so I can see them both, or they can both be imaginary. A degree 3, these are the combinations I can have. Degree 3, 3 real zeros, or 1 real and 2 imaginary, because those need to add up to the value of 3. If I have 4, degree 4, 4 zeros, I can see them all, and have 2 real, or 2 imaginary, or 4 imaginary. And then we extended it and we did a degree 5 and talked about those combinations. So our first example right here, the number of zeros that I can have for this problem, right? So determine the number of zeros for the polynomial. The degree is 4, so I'm going to have 4 zeros. I'm going to graph it. I want to identify the number of real zeros. So real zeros are where it crosses the x-intercept at, and then the number of imaginary. So the number of real zeros and the number of the imaginary have to sum up to the value of 4. So x to the 4th minus 81, I have it graphed. I know it's going to go through this negative 81 from my previous stuff. So I have that graphed, and that is not going to get pulled up nice and easily for me. So I have it graphed right here. X to the 4th minus 81 goes through a positive 3 and negative 3. So then when I come to my graph, I got 1, 2, 3, 1, 2, 3. It goes through those 2 points. Looks something like this. So the number of real zeros is 2, but the real zeros are at the value of 3 and negative 3. And then if I have 2 real zeros, I'm going to need 2 imaginary zeros.